Good morning, good afternoon, and good evening to all of our attendees joining us today for this latest Data Science Central webinar. This is Bill Vorhies, your host. I'm the Editorial Director with Data Science Central and also Chief Data Scientist for Data Magnum. So I'd like to start off our event today by thanking Springboard for sponsoring today's event. Springboard's a longtime supporter of the Data Science Central community, and we're honored to have them sponsoring our event today. Now, past webinars are available on demand at datasciencecentral.com, and if you haven't had the opportunity to view them, I encourage you to take a look. They provide some very useful insight into a wide variety of topics of interest to our data science community. Now, today's webinar is entitled Life as a Data Scientist and How to Become One, and that's going to be presented by Springboard. But before we begin, I'd like to briefly review the format of today's webinar. Today's event will be an hour long. We have one presenter who I'll introduce in just a minute. There'll be 10 to 15 minutes of Q&A following the presentation. And today's event is being recorded and will be available on datasciencecentral.com later this afternoon following today's live event. So I'd also like to encourage our attendees to provide questions throughout the presentation, as we'll be reviewing and presenting them on your behalf during the Q&A portion of today's event. Well, I'm very pleased to introduce today's speaker, Ryan Harter with Mozilla. Now, Ryan is a full-stack data scientist on the Firefox team. Previously, Ryan worked for Google and a few energy market consultancies. He's interested in building effective data science teams, building tools to make data science collaboration feel natural, and writing documentation that people actually read. So when Ryan isn't working, he spends his time mentoring students on Springboard's data science career track. So Ryan, hey, thanks for being with us today. We're looking forward to your presentation. Now, in today's Data Science Central webinar, you'll get an inside look at what it means to be a data scientist. You'll learn from practicing data science what to expect in your role as a data scientist, and we'll also discuss what a typical day looks like for a data scientist. So after learning what it means to be a data scientist, we'll walk you through the steps you'll need to take to become a data scientist, even without a degree. So we'll discuss everything from the hard skills to the soft skills aspiring data scientists need. And by the end of our presentation, you'll have a definitive plan on how to move forward in your journey toward data science. So Ryan, with that, I'm going to turn it over to you. You can start as soon as you're ready to go.
Great. Thanks for that intro, Bill. Hi, everyone. I'm Ryan Harter. I'm going to take you into our slides here. All right. So today's talk, Life as a Data Scientist and How to Become One. Here's a brief overview of what we're going to cover. So we're going to start off by trying to define what data science is, which has been a topic of conversation pretty openly on the internet. We're going to talk about different data science roles, the process of doing data science, and what that looks like. I'll take you through a day in the life of being a data scientist, and then we'll start talking about moving into data science and how you can bootstrap your career into data science. And we'll move into Q&A for a little while. So I'll start off with a question to get a feel for who I'm talking to. This question we're asking what you currently do, what your current profession is. Buckets are pretty big, so hopefully we can capture some information here, but I'm mostly looking to get a feel for who I'm talking to, what kind of work you're doing currently, and that'll help me gauge what kind of skills I can focus on for helping you bootstrap your career into data science. So I'll give you a couple seconds here to answer these questions. These are pretty broad, so if you don't fit neatly into one of these categories, feel free to choose other, and I'll just make some educated guesses about what kind of work you're doing. Great. I'm going to advance this and take a look at the survey results. Just a second here. Cool. All right. Well, nice. That's a pretty clear picture. A lot of analysts, which is pretty broad, but I think that makes a lot of sense to me. A couple of SWEs, students, and then, as expected, a bucket of others. All right, so about half analysts and software engineers. Great. So like I said previously, I'm going to start off by talking about, oops, my slides seem to be stuck. I'm going to start off by talking about what is data science. This has been notoriously difficult to define. And part of that is because data science is still relatively new. It wasn't really a discipline 20 years ago. And the other problem is that it's very broad. A lot of different companies define their data science roles differently. So I'm going to boost a definition off someone that I respect. Hadley Wickham has called data science the process of turning data into insight. And this is a pretty solid definition, I think. It's very broad. I'd say that there are a lot of people who are using data who wouldn't call themselves a data scientist. But if you're not using data if you're not using data to produce insights, you're probably not doing data science. So I'm going to try to narrow this definition down a little bit to be a little bit more colorful. I'm going to say the process of turning data into insight, especially when the data is very big, so big that it's difficult to look at it on one computer. So this is on the order of, like, say, hundreds of gigabytes or terabytes of data. Or separately, it could be the process of using data that is very raw. So this would be the classic example of, like, working with log data from a website, where you have date-stamped events like at 12:20, John Doe signed in. At 1 o'clock, he did a search, and at 2 o'clock, he bought something, turning that very raw data into something that's usable for the business. So that's a very high-level definition of what data science is. Let's start. Let me animate that a little bit. So I like thinking about data science. It's helpful to describe data science as how it benefits the business. So in my experience, businesses hire a data science team because they're picking up anxiety around their decision-making process. Very frequently, when you have to make a decision and you don't have all the information you need to make that decision well, it produces anxiety. Right? You feel like you're gambling with a business that you're not willing to gamble with. So I'll give you a few examples of what this looks like in practice. So I call it, this first example, I call it giving a business senses. And I work part-time at a brewery, and I like to use this as an example for how data science can add a lot of value. So when I work in the brewery, there are people who come in, and I see them, and they give me money, and I give them beer in return. And I can hear that the bar is really busy, and I can hear that we're doing good business that day. And I have a sense of, like, how the business is doing over time. For something that's as large and globally distributed as Firefox, that's really difficult to do if you don't give yourself some additional senses. And data science allows you to get a sense for whether your users are happy or unhappy, or whether a change that you've rolled out is actually useful, or if you just think it might have been useful. So this is the sense that data scientists give their organization. So the second pattern that I see a lot is grounding businesses in reality. So especially in Silicon Valley, it's pretty common to say that you are not the user. The people who are building products are generally not the same people that are consuming the product. And this causes problems sometimes when you build something that's really neat to you, or is very exciting, but when you roll it out to your users, it's difficult to understand, or it breaks things more than it helps. And this is characterized by businesses producing changes to the product that gives or yields unexpected results. Data scientists can actually measure whether your users are going to like what you're producing, or whether what you're building is good in their eyes. So they can keep you from having unexpected results. And the final pattern that I'll talk about is productionizing decisions. So a lot of large businesses get to this realm where they have a bottleneck at the executive team. There's more decisions to be made than they have time to make. And data science can help you take these decisions, productionize them so that you can delegate them to people without losing any of the without losing any of the color that the executive team has in those decisions. So this is of the form of, you know, if you can launch a feature change so long as it makes these numbers go up. You know, that's good enough for me. You don't need to involve me in every decision. Or if I'm not here and this number drops, you should start panicking. Both useful insight and something valuable that the data science team can contribute. So I've focused primarily on businesses that produce products, but there's a wealth of different businesses that make these types of decisions. This is just where I've had my experience. So we've talked about, we've tried to define data science. I've tried to characterize how that actually looks working inside of an organization. And now I'll talk about a few of the different data science roles. Here's the obligatory Venn diagram. There's been more Venn diagrams written about data science than I think any other profession. And so we'll talk about, let me advance these here. So there's, in an organization, they'll have what is called like a data program, and it's not usually called that just because the field's still very new. But there will be a class of people working with data, making it easy to make decisions with the data. So there's more than just the data scientist working at a company. If you have a very small company, it's possible that you have just one data scientist doing all of these roles. As you move into larger companies, they'll start to break these things apart for efficiency and scale. So in those roles, you'll have a data scientist that helps you phrase questions and pick out the right data to answer those questions and then communicate those results out. You'll also have data engineers. What the data engineers do is help you process data at scale. So if you're getting terabytes and terabytes of data a day, they'll collate that and get it into a form so that you can query it quickly and iterate effectively on data of that scale. So data engineering is moving the data around and making sure that it's accessible and usable. You may also have data analysts, which is, again, a very broad role. I characterize data analysts as people who have a lot of data intuition, but maybe don't have programming skills and maybe don't have a ton of statistical background. And then you'll have an operations team, which will, keep the computers up and running when you're trying to process the data and analyze the data on the front end. Cool. All right, so we've talked about data science in the organization, a bunch of different roles. Hopefully that was clear. Let me start talking about the data science process. So we've talked about what data science is, why organizations want data scientists, talked about some of the different roles that you could have that are kind of conflated with data science. Now I'm going to start talking about what a data scientist actually does and what that looks like. So here we have a flow chart. It's called the data science process. It defines what a data scientist does surprisingly well. So we usually start, I'm just going to take a quick pass through these before I start talking about it. But we start by defining the problem, getting a feel for what question we're trying to answer. And a lot of times you're also gauging whether this is a question that we should be answering, right? Whether this is important or whether it's well thought out enough to demand a lot of time to answer. Once we have a good understanding of what question we're trying to answer, we start collecting data. And this can take a lot of forms. It can be finding the data that we already collect that'll help answer this problem, or it can be creating a new experiment to collect data, to collect novel data that hasn't been collected before. So once we've defined the problem, collected some data, we go into this loop that is these bottom two squares here. And this loop is where most data scientists spend, like I'd say 50% of the time. And what that looks like is you have a pile of data and you look at it and you make some assumptions about it, and then you analyze it to see if those assumptions are right. And then you step back and you check your assumptions and make sure that they all still hold. So I call this the exploration and analyzing. So you explore, you just like list out some data and you make some assertions about it, and you do some analysis, and then loop back around until you completely understand the data. Well, sorry, you're never going to completely understand the data. You'll understand it well enough to answer the question at hand. And once you've moved through this, you can start communicating your understanding of the data to the rest of the organization. So in summary, you can define the problem, collect some data, understand what the data is saying, and share that with your boss. All of that's very vague, unfortunately. So I'm going to take you through an example project that we've worked on at Firefox. So I can't take credit for this analysis. I just happened to watch closely, and it's a feature that a lot of people understand. So I'm going to go ahead and appropriate it for this conversation. So the feature that I'm going to talk about is launching container tabs. What container tabs do is they let you isolate your personas to just a tab in Firefox. So you can have your work email open next to your personal email, or you can have you can have Facebook just like hidden over in its own tab, and they can't see what you're doing in other tabs. This is a classic example of a feature that is super exciting to someone who's building a browser that is really difficult to communicate to users who just use the internet on their computer. So this is a perfect example of something where data science can ground the organization in reality. And with all questions like this, we start by trying to understand what the problem is. So part of that is meeting with the creator, understanding what the feature does, and trying to understand, for example, what the failure cases are. I'm actually going to move to the next slide here. There we go. So yeah, we've talked about, we have container tabs, and the first step is understanding the problem. You meet the owner, you sit down with him, and you ask him, what does this do? What are you trying to do with this feature? How does it break the user experience? What are the risks associated with launching this? And then you ask them, how could we win? Why do you want to launch this? Why is it good? And then something that's not listed here, but we still have to ask, is what shouldn't change, right? What would be surprising to you if it did break? And that helps us figure out what type of data we need to collect. So with container tabs, there's a risk of like performance loss, and there's a risk of like website breakage, for example. If users can't access their personas in every tab, it could be that they can't log into some things that they think they should be able to. But it should increase retention because people get really excited about using this feature. And we move into collecting some data. And this conversation usually starts with, can we use data we already have and run a descriptive analysis, which is easy because we don't need to collect more data? Or are we trying to establish some type of causation? And if we're trying to establish causation, we need to move into an experiment where we collect new data about our users, which can be expensive in time, but produces much more usable data. I might be getting into the weeds a little bit here, but there's a lot of depth here that a data scientist can provide to the organization. And then separately, if we need to collect new data, how can we do this while still preserving users' privacy, which is something that we focus a lot on in Firefox. So at this point, we've met with the owner, we've talked about what data we're going to collect, and then usually the data scientist prescribes what type of data we should collect and then hands that off to a team of engineers or hands it back to the product team to instrument and gather all that data. We pick back up then at trying to understand the data that the client team collected. So for example, if we've run an experiment here, you can take a look at tests and control, and you start to try to understand why the results look the way they do. So you can see maybe your error bars in the data are really, really wide. and you say, okay, that's weird. I'd like to understand why that is. So you jump into the data and you say, why is it so noisy? You plot the data, get a distribution, say, there's really big outliers there. So you get rid of that, and now the data makes more sense. You explore a little bit more, and you realize that retention might be decreasing. So you go in and you investigate, why are users leaving? This is the loop that we talked about before of exploring and analyzing the data. And then you can go into things like, what are the possible loss scenarios? Are there any performance losses? So you keep looping through between analysis and exploration until you've stopped getting major questions from the data set. Things stop looking weird. And at that point, that's what I call understanding the data. Once you understand the data, it's time to kind of step back and get your analysis into a state where the rest of the company can understand what you understand. And this usually, so it looks really messy once you understand the data. And a lot of times this looks like you go off for a week and you just explore and you kind of like put yourself in a corner and your hair gets messy, you're typing away, and it's kind of crazy. Cleaning up and communicating is a big part of the job because it takes a lot of time. So in my work, I try to produce textual reports with a lot of prose because it helps my reader understand, and it can hold a lot of context without confusing the reader. Some people prefer to sit in meetings and explain what they've found. I found that there's less confusion when I write it down, pass it out, and then consult in meetings just like 10, 15 minutes if I need to. And in the communication, we talk about encapsulating the full launch and no launch decision, right? So if we have container tabs, I want to write down, here's container tabs, this is what it does, this is why we're deciding to launch it, because it makes these metrics go up. We didn't see any change in these metrics, and we saw a small decrease in these numbers, but right now that's reasonable to us. So encapsulating this full, all of the information going into the decision with the goal of being able to overturn that decision in 5 years if we need to. That's the gold standard of including enough information in your reports. So, all right, that's a lot of talking. Let me step back and explain where we are right now. So we just talked about the data science process, which takes you through, for one project, how does a data scientist attack a problem and solve a problem for a business? Then I took you through an example for one project, these container tabs. But it's very common for a data scientist to have, 3 or 5 projects going on at the same time. So a day usually looks very different than that pattern that we were talking about. So we'll talk real quick about tooling here. Actually, I'm going to skip forward. So we talked about the long pattern. Let's talk about what an actual day looks like. And a data science day is split in between 3 major categories. So only about 1/3 of my time is spent analyzing data, right? Actually digging into the data and pulling value from it. I'd say about 1/3 of my time is spent meeting and scoping analyses with client teams, right? So trying to understand the problem. And this actually, you have to, I'd say like, for every 10 problems that someone brings to me, I usually only investigate 2 of them because a lot of it can be answered with, it'd be nice if we could have data, but collecting data is expensive enough that we don't need it for this question in particular. So I spend about 1/3 of my time talking with people, trying to understand the problems that they have. Spend another 1/3 of my time reviewing other data scientists' work and answering questions for client teams who are like, I need to know how many users we have in Germany. So that's just a really quick query that I can just pump out and answer their question quickly. So we said split about evenly between analysis, meeting and understanding the problems, and answering questions. And that mix will change significantly as you go up and down in seniority. Very junior, data scientists will spend a lot of time doing independent analysis, or very senior scientists will start talking about just defining problems and just doing review for other data scientists. So I'm going to bounce back. You might have saw this when it popped up, but I want to talk a little bit about tooling, what type of technologies I use when I'm doing this kind of work. So big debate in the data science world is what's better, R or Python. I use Python right now. I used R before. I use Python now because we have really good support for PySpark, and Firefox or data is very big, big enough that you need some advanced tooling to be able to analyze it. So I use Python because it's what we support. R is a great choice as well. I just don't use it right now. A lot of this analysis happens in Jupyter Notebooks, which are a great way to explore data. But once you get to the stage where you need to communicate the data, I tend to work with Markdown in documentation that has a lot of prose with it, or GDocs if I need to get collaboration from a lot of different people. And I prefer to keep all of my analyses in a Git repository and host it on GitHub. If these don't sound familiar to you, take a look. It's probably worth some time getting to use them because they're really great tools. And it produces analyses that share and age really well. So, all right, we've talked about a day in the life. Let me step back, summarize again what we're talking about. So we started by defining data science. We talked about how data science produces value for an organization. We've talked about the different types of data science roles you can have in an organization. We talked about what a data scientist actually does, and we've characterized that by looking at a single project over time. And then we've also talked about what a single day looks like. Now I'm going to take a pretty big jump and start talking about how you can actually get into data science. So data science is a pretty cool profession because it touches a bunch of different areas. So there's a lot of software engineers who are close to being a data scientist, a lot of analysts who are close to being data scientists, and statisticians who are kind of close to being data scientists. So they just need to round out a couple of skills to be able to produce a lot of value, or to become a data scientist. Sorry. So I'm going to pop up a question here so I can understand where you guys are, or you folks are, on programming skill and statistical knowledge. So this question, it's looking for, do you have experience with programming? And it starts from, no, I've never touched it, to I've done a little bit of coding. I'm not sure that these are necessarily directional because there's some folks who have done a couple of programming courses but haven't really used it. And then significant for our purposes are you've coded a lot or you've coded professionally. And again, I'm just trying to get a rough feel for how much programming experience you have so I can kind of talk more or less to the tools and technologies you can use to get started. All right, let's take a look at what you all had to say. Cool. All right, this is a pretty solid mix. It's a pretty flat distribution. Little less than half of the folks have pretty significant programming experience, and then a little more than half have something, but not a ton. Okay, that's interesting. Thank you, everybody. And then I'm going to follow that up with a question about your statistical background. So here I'm looking for, have you taken any stats classes? Is it something that you feel comfortable doing? And there's probably another category in here between average and significant. If you've taken more than one class and you feel pretty comfortable with t-tests, go ahead and bump it into significant. And then we can, that'll give me a pretty good feel for what kind of statistical background you have. I'll just give you folks another 10 seconds to take a look at this. And then we'll talk about the major categories of skills that you need to do data science. Great. Cool. All right, and this looks as expected. There's most folks have done a little bit of statistics, but maybe don't feel like they're experts. Great. Well, thank you, everybody. As I promised, we're going to talk about breaking into data science, and part of that is getting a feel for what skills you need as a data scientist. And this is actually something that I really like talking about. I have spent a lot of time interviewing over the past 4 years or so. I've probably conducted somewhere between 150 and 200 data science interviews. I have a pretty good feel for how people tend to evaluate data scientists and what skills are super useful to get into the field. You can break them up into 4 major categories. These technical skills, which is a little bit of a misnomer, but this is better described as programming skills. People are technical programming, that kind of stuff. You need some skill in statistical modeling and just general statistics. You can talk about these are the softer skills, communication, and then data intuition. And I'll get into each of these in just a second here. So technical skills, like I mentioned before, there's this debate between R and Python. Both are great, but you need skills in at least one. I haven't really seen any shops that care about whether you know R or Python. So long as you know a programming language and are able to analyze data in it, that seems to be sufficient for getting into the field. If you need to with the company, they usually will let you learn on the job if you're just trying to learn the syntax of the new language. But that being said, they are very different, and they will have different advantages for when you're getting started. Python as a language is maintained by programmers. So if you start with Python, you'll tend to have fewer bad habits when you start off. I call them bad habits, but that's not really a great characterization. But R is maintained by statisticians and people analyzing data. So you'll have tools built for analyzing data if you start with R. So you can have some quicker wins with R, which can be really motivating. But Python will probably set you up for more general purpose programming skills. SQL comes up very frequently. SQL, I call it data's lingua franca. You should understand some SQL, but in my experience, you don't need to get too deep. You should expect maybe a question that's phrased as a SQL question, here's a data set, manipulate it to produce a couple of summary statistics. So you should feel comfortable writing a SQL query on the fly. Maybe it would need to have a select, a group by, an order by statement, and a limit. I wouldn't worry too much about getting really deep into functions and all that kind of stuff. Data visualization comes up pretty frequently. This is a little bit of a misunderstanding in my view. Data visualization is its whole field, kind of separate from data science. You could spend the next 30 years becoming an expert in data visualization and still not be a data scientist. They do share a lot of overlap, but for a data scientist, you should focus on learning a package that will help you explore the data. There's this idea of exploring data versus presentation. The New York Times, when they put a graphic on their front page that is interactive and helps you understand data very intuitively, I consider that presentation. The problem with those types of graphics is that they take a lot of time to produce, and when you're trying to understand a data set, you need to iterate very quickly so that you can test hypotheses and generate new hypotheses with a really quick feedback loop. So focus on graphics packages that help you produce images and explore data sets quickly. And I'll try to characterize each of these skills with the type of person who interviews well. Software engineers tend to interview very strongly in technical skills, which is as expected, I think. Talk about statistical skills. In most companies, or many companies, data scientists function as statistical consultants. They'll sit down with the team and they'll help them understand whether the conclusions they're trying to draw make good sense from the data. Statistics in general is kind of changing, especially if you're trying to pick up statistical skills. In the past, statistics has been guilty of having a lot of magic formulas and giving you quick, high-level understanding of a few tools to do statistics without giving you a deep understanding of the mechanics going on behind the scenes. This kind of changed when we started focusing on resampling, which gives you, it's easier to understand and grok what's going on there behind the scenes. So if you're trying to learn statistics, I'd recommend focusing on resampling instead of some of the magic formulas. You should understand what hypothesis tests are. And there's this debate between, there's this schism between frequentist and Bayesian statistics. I won't really speak to which is better, but I can say that most of my peers are frequentists. It just seems to be an effective way to do work. So that's kind of high level what you should be aware of in statistics. You should also know what an experiment is and why people use it. If you're trying to look for more senior roles, you should understand a part of statistics or a field of statistics somewhat deeply, at least so that you can talk about it in, you can talk about how you would solve new problems with statistics. In my experience, you will be evaluated on your statistical knowledge in interviews, and that's for two reasons. It's very critical to the job, but it's also very easy to test in a 30 or 45-minute interview. So just be aware that you'll probably get some type of a coin flipping question if you're interviewing for a data science position. And obviously, this is the field where statisticians tend to be strongest. Data intuition is third category I'll talk about. This is more difficult to define, and because it's difficult to define, it tends to be a little undervalued in the industry. But what I call data intuition is the instincts you get from working with data for a while. Helps you guess what avenues should I pursue with this data set? What smells funny about this analysis that I'm looking at? And what type of data should we be looking at? Unfortunately, this skill is learned with practice, working with real-world data sets. In my experience, folks who have spent a lot of time in school trying to understand data science, they haven't worked enough with real, messy, real-world data sets to be able to develop a lot of data intuition. What do you do with nulls? What do you do when the data comes in as a tab-separated pile of text instead of something that's actually usable for data science? So this is a whole set of skills that people build up over time, but is a little undervalued in the industry right now. And it's very difficult to evaluate during a data science interview. So be aware that this is something that you should be good at, but will take some time to build up the experience in. And this is where data analysts tend to shine the strongest, because they've worked with a lot of data but may not have a background in statistics and programming. And then communication, always super important, but with data science, very, very important, because you go into this world where you understand the data completely and it takes a lot of time, and then you need to distill that to something that the company can use. Writing is super important for data scientists. Unfortunately, the best advice I've gotten for becoming a good writer is be a bad writer for a while and do a lot of writing. I can recommend On Writing Well, which is a pretty classic book in writing nonfiction in a way that people can understand. And then kind of separately, I talk about confidence and tuning your message to your audience. If you're talking to an exec team and they ask you, are you sure about these results? And you have 99% confidence at a statistical level, yes, you're sure. Don't bring up that level of unconfidence, because that's not what your team's asking you for. And this skill is, again, knowing what to include and what to not include in the final report. You need to make an understandable final presentation. So in summary, these skills, I've listed 4. To have a good chance in an interview, you need to be impressive in one of these vectors, satisfactory in the remaining vectors. You have better chances if you go kind of deep into two of these vectors. Cool. So I'm going to talk about a portfolio. It's great that these skills are listed and that you know that you need them, but building a portfolio is actually something really important. Portfolio will give you two things. It'll help you work end-to-end through a data science problem, which gives you some experience building data intuition and some experience communicating the results. And not only does it give you the skills, it'll help you work your way through the first stage of an application, right? So the way that these applications work, as I'm sure a lot of you know, is you have a hiring manager who's not a data scientist looking at a bunch of resumes and trying to gauge who knows what they're talking about. And if you have some code and some analyses up on the internet or included in your resume, that gives them a lot of confidence that you do know what you're talking about. Your hiring manager will take a look at that and be like, oh, awesome, this person's actually worked with real-world data before. I don't need to evaluate this in interviews. So two big advantages of portfolio there, and mentorship. So mentorship provides a lot of value when you're trying to get into data science. As I'm sure you found, it is a very broad field that contains a lot of different disciplines. If you have seen the open source data science masters, it's a list of readings that'll take you from neophyte to practicing data scientist, just by reading a bunch of stuff online, but it looks like it's about 10 years worth of reading to someone like me. Something that your mentor can do is they will look at the code that you're writing, and they'll look at the analyses that you're doing, and they'll say, okay, here's a problem in this. Here's a chapter of a book that you can read to get better at this. And the option, if you don't have a mentor, is I guess I'll just read everything in the open source data science masters until I find something that I'm not doing well. They can target your learning material to you and help you advance faster. They can also provide, well, they will always provide guidance and accountability. They'll say like, hey, maybe you should focus on your communication skills in that interaction. Maybe you should have been a little bit more confident in your results, or maybe you should have backed off a little bit. You expressed too much certainty. They'll also help you learn the language that we use in data science so that you can communicate effectively with your peers and express yourself clearly. And then career advice. It's a new field, so having somebody that has some experience is super useful when you're trying to get started. Now, these tips by themselves aren't super useful. I'm here today because I mentor with Springboard's data science program. So Springboard, what they do is they help you bootstrap your career by giving you experience, helping you work through a capstone project, and hooking you up with a mentor who will look at your work and provide you with all those benefits of mentorship that we just talked about. They have career services to help you find the job that you're looking for, get started in that role, and talk effectively with the people who are hiring. And like I said, they help you bootstrap by giving you experience in these skills that you need to learn through practice, communication, data intuition, and finding out how to improve through mentorship. So here's some facets of the career track. Most of the students who come through the career track are looking to upskill or are trying to either shift their career from like an analyst position into data science, or trying to just jump ship and work with data. Data is a huge field right now. It's growing because we're collecting more data than we ever have in the past. So it's a great place to start shifting your career if you're looking for something that's stable or growing. Like I said, we focus on hard and soft skills, building a portfolio, getting a resume that gets read, and building the confidence necessary to succeed. The course is self-paced. Most of our students are working full-time and then working the course part-time. It takes about 15, 20 hours a week. Cool. And if you're interested, reach out to Katie, who handles the data science course at Springboard, and you can apply through this link. I'm going to hand that off to Bill to switch over to Q&A. I want to give you all plenty of time to ask us questions.
Hey, Ryan, thank you for that excellent presentation. So we'll get started with today's Q&A session. And I want to thank the audience for their participation. We've had a lot of questions that have come in. So we'll do our best to get through all of them in the time remaining. And during this Q&A session, I'll leave up this screen with contact information for Ryan in case you'd like to get a hold of him following today's webinar. So Ryan, let's get started. You talked at the end there a great deal about the value of having a mentor. Did you have a mentor in your early career, and what did they add for your experience?
Yeah, I've had a couple of really great mentors at past jobs that I've had. So early I was a consultant. I had a couple of mentors, or one mentor in particular, who helped me really understand communication and expressing confidence in a way that was tuned to the audience that I have. So he would say things after the meeting like, hey, great presentation, but the way that you said it didn't really resonate with the people. I could see on their faces. Next time, try doing it a little bit differently. And that was great, because that's the type of improvement that I have a really hard time making and even realizing that I need to make. So having him give me that direct feedback was awesome. And for programming, I've had a bunch of great peers who have given me awesome code review. I'm a self-taught programmer, so having professionals who went to school for it look at my stuff and say hey, maybe stop repeating yourself so much in your code has been the best way that I've improved.
Oh, cool. Well, thanks for that insight. A lot of our audience members are interested in obviously getting into data science, but they come from a non-technical background. So, the question is, first of all, can you come from a non-technical background and get into data science? And specifically, how much math or computer science is needed to get started?
Yeah, to get started. So I've seen some successful transitions where people have started from non-technical roles, started working with data on a smaller scale, getting comfortable drawing some information from data, phrasing their questions in a way that can be answered with data, and then slowly ramping up into understanding programming, using more and more powerful tools, and starting with very little statistical background, but then digging in and chipping away at the statistics. It can be a really big task if you're doing it on your own. So expect that to take some time. If you can get into the place where you're doing it professionally, you'll start moving much faster. And this is one of the things for the Springboard thing. It's really great because they'll get you bootstrapped so you can get a job, and then you can start focusing really heavily on building these skills professionally.
Well, thanks. Thanks for that answer. Now, folks are interested in knowing how to get started in data science literally from scratch. These not necessarily non-technical folks, but folks that want to first get started. And of course, one way is to get a degree from a university. There are open source platforms like your own. What would you recommend for folks who really want to self-teach?
So the open source data science masters is a great source of reading material. So I should preface this by saying expect it to take a lot of time. It is a pretty full career. And if you want to self-teach exclusively, the open source data science masters is a great way to get started. If you work through that material, you will eventually be very proficient. Be sure to start by working with data, though. You can read a lot, but until you build that data intuition, you're going to have a really hard time being effective as a data scientist. Yeah, I think that would be my advice.
Okay, terrific. And I think that some folks that are hearing this message for the first time and hear us talking about programming misunderstand about the difference between data science and just learning another programming language. Can you speak to that issue?
I'm sorry, can you repeat that? I lost it for a second.
Yeah, learning data science is not just learning another programming language. There's much more to it. And yet when we talk about programming, it seems to some folks that, oh, gee, I'm just out learning another programming language.
Right, yeah. No, it's very different from learning a programming language. There are data scientists who are effective that don't have any programming skills. The more and more I think about where the value from data science comes from, it comes from phrasing these questions effectively, digging in and understanding what the problem is, and trying to phrase that in a way that data can answer it. So data is a little expensive to answer questions with, right? It takes a lot of time to collect the data and to understand what the data is saying. But like we've talked about, it scales better to much bigger businesses. So understanding what questions you can and can't answer with data, that's where like the pure gold of data science is. Programming helps you iterate quickly and understand the data more quickly, but it's just one stage of the data science process.
Right. Well, thanks for making that clear. Now, you talked a little bit about the open source masters as a source of training. Are there other training sources that you would mention? And by the way, why don't you go ahead and compare them to Springboard?
Right. Yeah. So I've mentioned the open source masters, and it is a lot of good information, but it's not guided, so it can take a lot of time and it can feel very overwhelming. And it's comprehensive, but you don't need to be comprehensive to be successful. You need, like I said before, depth in maybe one of these 4 vectors and then some experience in each of the other vectors. So if you just dig in and try to look at everything in the data science masters, it's going to take a lot of time and there's going to be some wasted effort where you could have been working in a job and building the rest of these skills out. Compare that to Springboard, where you have guided mentorship that'll help you find the important things for the career that you want. Most data science roles are a small subset of all of data science. So you can like pick the parts that you really enjoy and not do the parts that you don't really enjoy. A mentor can help you build out that learning plan, and Springboard's curriculum is really good at getting you started, getting you enough to get into a position where you're working. And then once you're working, you can build out the rest of the skills since you have 8 hours a day to work on it.
Thanks.
You asked me specifically about other resources that we could look at. Kaggle comes up pretty frequently, but in my experience, Kaggle seems to be focused more on machine learning, which is, again, closely related to data science, but you tend to have data that's very clean, which makes it a little difficult to pull data intuition from the data sets they have there. They also tend to be obfuscated so that you can't really understand what the source of the data is for privacy reasons, which, again, kind of stunts what you can learn from data intuition.
Right. Well, thank you for that answer. And, we were talking briefly about, in your presentation, about the preference for R or Python, but the audience asks appropriately, what about SAS? Is SAS still worth looking at?
Yeah, there are some shops that use SAS. It is very useful. I've found SAS to be used more in economic modeling, which I did a little bit at the beginning of my career. SAS, so in my experience, SAS has a couple of drawbacks that keep it from being mentioned at the same time as R and Python. It tends to be expensive. So if you're trying to do analysis on your own or trying to learn, it's very difficult to work with. A lot of companies don't want to have a lot of SAS licenses, so it kind of comes as like a extra cost to hiring. Though small, some businesses really focus on that. And because it's closed source, it's hard to hire for a lot of people who understand SAS. R and Python are both open and are both fairly general purpose programming languages, so they tend to be more prevalent in the industry.
Well, thanks for that insight. Let's turn back to some of the non-technical issues. Audience is interested to know, well, okay, so I have these technical skills. What are the important soft skills that I should have?
It's a really good question. So we talked a little bit about the communication. So let's talk about defining the problem. When you're defining the problem, you're going into a team who's worked very hard on a feature. So in my experience, I work a lot with feature launches. So I'm going into a team that's worked for the last year on this feature, and they're ready to launch it. And right before launch, I come in and say, "Is it any good?" Which is not a fun question to hear if you've been working on something so hard. So being able to ask questions in a way that challenges what people think by default, but also gets to the root of the trouble. So those communication skills and being able to ask effective questions is a great soft skill to have. Like I mentioned before, communicating in writing is really important, and being able to express yourself confidently in a group of people who probably outrank you are some of the soft skills that you really need.
All right, terrific. Oh, thanks for that insight. You know, we have an audience member who has taken some classes and is wondering how to build up a portfolio of real-life examples since he's doing a different job at the time. And at the same time, perhaps you'd like to talk about the fact that Springboard focuses on that in their plan. I understand that Springboard requires you to do 2 capstone projects.
Right, yeah. Springboard comes through with 2 capstone projects, and they kind of increase in, not difficulty, but comprehensiveness, I'd say, as you get through the course. So you start off kind of breaking the ice with an early capstone, and near the end you have, you complete the capstone and you have all the skills that you need to kind of get started in data science. So it tends to be a little bit more comprehensive. And in those capstones, you choose a data set from the real world. You find a client, either real or someone that you've devised that has a question that you're trying to answer from the data. You find some real world data, you clean it, you explore it, you draw some insight from it, and you package that in something that you could actually deliver to a client. So the course is great because it guides you through that. If you're trying to do that on your own, a couple of the tips that I have are, try to find data that hasn't been cleaned for you beforehand, and try to imagine a real client that actually needs to get value from this data set. That second part, imagining a client and trying to understand what they want, I understand it's very difficult if you haven't been in the industry. One of the first things to figure out is, what do people actually want from a data scientist? And that's something that a mentor can really help you phrase well. So finding somebody in the field who can help you answer some of these questions is also pretty important.
Well, thanks. Thanks for that answer. Just time for one more question. Broadly, what types of challenges should people in data science role be able to handle? It can't all be simple.
So there's a couple of problems that you'll run into. I'll talk about some of the broad themes. Getting people to use data to make decisions is kind of difficult because it is slower than just making a gut call. And it looks like you can be, just blocking because you're not sure when they are very sure in their guts. So getting buy-in when you're trying to keep people from just launching things for the sake of it is difficult. And explaining the uncertainty that comes from data in an effective way is also kind of difficult when you're talking to non-technical folks. This is one of the areas where folks coming from non-technical backgrounds tend to succeed really well, because they've recently gone through the struggle of trying to understand what data is and how to use it, so they're able to communicate that to non-technical folks really effectively.
Well, Ryan, thank you. Those were some great answers to some very good questions. And for those of you that asked questions today that weren't answered, we'll be sending all the unanswered questions to Ryan and the Springboard team so they can follow up with you after today's webinar. I have just a few quick announcements. If you'd please mark your calendars for June 14th, that's just 2 days from now. That's our next DSC webinar, which is Harness the Power of Big Data Analytics, and that'll be presented by Trifacta. Also remember that today's taping will be available for on-demand viewing later today, and you can find that on the homepage of Data Science Central in the Webinar tab located at the top of the page. Well, this brings today's webinar to a close. I'd like to thank our audience for their attendance and thoughtful questions. A special thanks again to Springboard for their sponsorship, and particularly our speaker today, Ryan Harter, for his insight into today's topic. This is Bill Vorhies. I'm very pleased to have been your host for today's event. I look forward to seeing you all again on June 14th. Have a great day.